Welcome to our video lesson on 13.3, all about our stress hormones. We are going to look at the adrenal glands where all the stress hormones are produced. There is an outer area called the adrenal cortex that releases aldosterone and cortisol, and there is an intersection called the medulla area that releases adrenaline. So those are the two that we will be two areas we're going to focus on. And we'll start with the middle area, the adrenal medulla. You will find very familiar because the effects of adrenaline, also called epinephrine, are exactly the same as the effects of the sympathetic nervous system. So what happens is the adrenal medulla is going to be stimulated by neurons, and that will make the adrenaline release. Remember, the sympathetic nervous system responses are faster. However, they don't last as long. So when we need something that could be a life-threatening response, we also have a hormone, adrenaline, that will take over and continue that for a very long time. So if you're fighting a fire and they say you're able to do that on adrenaline, basically what happened first is the sympathetic nervous system got the body all ready to respond, and then the hormone adrenaline kept that going possibly for hours. Before we look at those effects of adrenaline, we can look at an actual image here of what those adrenal glands look like and how large they are. Just that right there, sitting on top of the kidneys. Convenient location, seeing as the aldosterone is targeting the kidney in terms of its job of water reabsorption. So the other name for adrenaline is epinephrine, and we have norepinephrine, also a very similar compound that will cause all these very familiar sympathetic nervous system responses. And so you may recall that includes increasing your breathing rate, increasing heart rate, increasing blood pressure, releasing sugars for those vital organs to use, particularly muscles, increasing metabolism, blood flow to the muscles, slowing down digestion, and relaxing walls of bronchioles, dilating pupils. You may have heard of epinephrine being used in an emergency, and some of you may even have EpiPens with you. So what EpiPen can be used for would be things like dilating bronchioles if an asthmatic is having bronchial constriction, maybe also helping with blood clotting in case of a hemorrhage and an injury, and also during a cardiac arrest, stimulating the heart. They have given those for allergies or anaphylactic shock as well. So you can read all about that on page 452 and make your list. So we have seen this list before of what the sympathetic nervous system will do, and again you'll see how it is exactly the same as what adrenaline response will be. So we call the response of the adrenal medulla a short-term stress response because it is when the heart rate and blood pressure increase and blood flow goes up and breathing rate goes up, they consider that a fairly short-term, even though it lasts for hours, it's a fairly short-term response. And you can see in this image how the nerve tracts from the hypothalamus are going through the spinal cord and actually directly stimulating the adrenal medulla. Here's our feedback loop. Please add this to your list of feedback loops. where I drew in that it is a neuron that stimulates the adrenal medulla to release epinephrine. And there's your list of effects. And then there's the negative feedback arrows that will stop it when those effects are completed. So please pause the video and add this to your feedback loops. We are going to do the second part of 13.3, talking about the outer adrenal gland, the cortex, and one of the hormones that's released from there is cortisol. These are a long-term stress response, which it can actually be going on for very long periods of time when the body is under stress. So the hypothalamus then is going to release ACTH, adrenocorticotropic hormone, to tell the anterior pituitary to, the hypothalamus causes a releasing hormone to tell the anterior pituitary to release ACTH, and that will cause the release of cortisol from the cortex. You can see in this image the jobs of that cortisol will be to break down fats and proteins in order to get glucose up. And glucose is going to be vital for cells that are under stress, muscles that are needing energy. And so instead of using potentially or depending on sugar in the blood, fats and proteins are used to turn into glucose for the cells to use. In that process, though, the immune system gets suppressed if the energy is going towards breaking down fats and proteins. So this is one of those effects that is not a good one, but that does happen. So you'll see how that will affect people with an overactive adrenal cortex. So here's our list of 4 things. Muscle proteins are broken down. This will also allow amino acids to be floating around and help with healing if there's injury. Fat cells release glucose. There is an anti-inflammatory effect on the body when cortisol is released, which is why cortisone shots are sometimes used for that same effect. But there is a suppression of the immune system. So people with long-term stress tend to be getting those effects of having a low immune system and feeling kind of weak and sick after a while. So we have this picture that just shows that cortisol is released from the cortex, but it also shows that there's another one, aldosterone, that's released from the cortex as well. One of the things I mentioned with high stress is that we can have infections, high blood pressure, diabetes, foggy brain, heart damage, and even early death from chronic stress. And cortisone can be used for decreasing inflammation in joints, asthmas, in arthritis. The problem with that, we need to have caution because it can be damaging to tendons and ligaments and cause weight gain because of all the glucose that will be put into the bloodstream. And then muscles will be basically shrinking, but there'll be fat potentially collecting. This is a couple slides, not in your curriculum, but just about adrenal fatigue. And sometimes stressors, as you can see in this list, you can pause and just read those life stressors that can end up having people feeling these on the right, things like depression and fibromyalgia and body pains and autoimmune disorders and allergies they never had, weight gain, a lot of like ongoing fatigue. And they have been looking at how potentially all these stressors are affecting your adrenals, and it's actually adrenal fatigue that has to be addressed. So there's just some cartoons. You can take a look at these on the PowerPoint that kind of summarize the effects of adrenal fatigue, the long-term illnesses, the constant fatigue, craving salt, can't handle stress, no energy, mild depression, and less enjoyment in life. and having foggy memory, low tolerance, decreased productivity. So that's just something like as an awareness thing to be aware of how your adrenals can be affected by those situations. The second hormone coming from the adrenal cortex is aldosterone, and you've heard about this before because it's the one that causes your kidneys to, nephrons in the kidneys to reabsorb sodium and potassium, causing water to follow those salts and increasing water reabsorption and blood pressure. So it's called the mineral corticoid because it causes minerals to be reabsorbed and then water follows. Third one, you don't have to know this, but it sure explains the conditions, when there is problems with the adrenals. So adrenals cortex is an area that releases the opposite sex hormones. So in females, that some testosterone is released from there, and in males, some estrogen. And if you have a tumor or overproduction of the cortex, then that's why a female can get masculinization and a male femininization because of those opposite sex hormones found in the adrenal cortex. So that brings us to the disorders associated with the adrenals. If there is an underactive adrenal cortex, then we'll have trouble with balancing those sodium and potassium ions, and then low blood pressure will result because they're not getting released. Aldosterone is not getting released, and they're not going back to the blood with water following. We've got fainting and infection problems, stress problems, weight loss, bronzing of skin, and can't really explain the bronzing of skin, but maybe it's messing with the proteins in a way that causes that as a side effect. So with Addison's disease, you can see here that the bronzing is basically, and pigment is collecting in different places in the body is one of those symptoms to look for. The other is overactive adrenals, and that's Cushing's syndrome. So if you have too much cortisol that's breaking down your muscles, people end up with skinny arms and legs, but subcutaneous fat builds up. So they actually get like stretch marks on their abdominal area. They can get, females can get this basically masculinization and hair growing on their face because of those opposite sex hormones being released, atrophy of muscles, but then collection of fat in other places, including the face, which is why moon face is actually a symptom of Cushing's syndrome. So this patient with Cushing's who was treated for it then recovered in 2 years to look like this. So there is in this case, a very reversible and treatable outcome. With the subcutaneous fat, that's what the stretch marks, those striations look like. And there it is again, skinny arms and legs and subcutaneous fat building up. There is a good video link about Cushing's. I suggest that you check that out. Take a moment to pause and write down our 2 feedback loops for the adrenal cortex. Hypothalamus sends out releasing hormone to the anterior pituitary for ACTH to cause the adrenal cortex to release aldosterone, and in turn the kidneys will reabsorb salts to reabsorb water. The other one is when the adrenal cortex releases cortisol to break up fats and muscles, to increase our glucose levels and decrease in inflammation. Cushing's and Addison's is mentioned here in the over and under secretion to list your disorders. So take time to make those two other feedback loops and add them to your list. To wrap up, guys, there is a couple of really good videos on adrenaline to have a look at. So check that out. Thanks for joining me for 13.3. Bye.